Hi there. In this part, we are going to design the architecture for our image moderation app. First, a quick review of the requirements. The user should be able to upload their image files through a web page or a website with maximum file size of 5 MB, and the accepted formats are JPG and PNG. Once user uploads that image, the system should analyze it for any restricted categories. If the image has any of the restricted categories, the system should email the user and inform that their submission is under review, and should also inform the platform admins that a submission has come in that requires human review. On the other hand, if the image does not contain any restricted categories, then it should send a confirmatory email to the users indicating that their submission is live. So think of it as a photo sharing app where the users can share their photos with the wider world. But before the photos are made public, the platform needs to check whether those images or the photos contain any restricted categories like violence or sexual depictions, etc. etc. So this is essentially what we are trying to achieve by building this app. So now that we have seen the requirements, let's try to decompose our system into different components and map the required AWS services in order to achieve it. So first and foremost, we are going to need a user-facing website. And for that, we are going to use Route 53, CloudFront, ACM, and AWS S3. The website is going to be pretty basic, HTML, JavaScript, and CSS. And those files we are going to host it in S3. We are going to use Route 53 to create our custom domain. And we are going to use ACM to enable HTTPS. And CloudFront is for the distribution. Okay, now we have the website, we will need a mechanism to upload the images. And for that, we are going to use API gateway, Lambda, and another private S3 bucket. So this bucket will be different from the bucket that we are going to use to host our website files. The second S3 bucket will only host the images that the user has uploaded. And now that we have images on our side, we need to process it. But before we process the image, we need a mechanism to decouple the upload part and the processing part of our application. And it has several architecture advantages. For example, let's say if we have a sudden spike in uploaded images, so let's say a lot of users are using it at the same time, and our processing is not able to keep up with that volume, we do not want a negative user experience where either the website becomes too slow for them to upload the images, or worse, some of the uploaded images are lost and the processing part never picks them up. So Amazon SQS is a wonderful way to decouple different parts of the application. It will ensure that it will absorb the traffic spikes if they come in. It will ensure that none of the uploaded images are missed. So even if they are not processed immediately, they will stay in the queue, and as soon as the bandwidth become available on the processing part, it will pick up those images and start processing the images. Next thing that we are going to do is design a mechanism to orchestrate the workflow. And for that, we are going to use Lambda and step functions. So what is this workflow going to look like? So first, system is going to take the image that the user has uploaded and now which is present in our S3 bucket, send it to Rekognition. Rekognition will return the image categories back. Then our system should check whether the return categories from Rekognition contains any of the restricted categories. And when Rekognition returns the categories back, it also returns a percentage, how confident it is that it contains certain category. And based on the categories and the percentage, then the system has to make a call whether to take that image live or send it to the administrators for review. And that whole workflow we are going to orchestrate using step functions and Lambda. And as I said, for the analyzing image content, we are going to use Lambda and Rekognition. For categorizing the image, cleared versus ones that require review, we are going to use Lambda and S3. So where does S3 come in picture here? So let's say the image doesn't contain any restricted categories. we want to change the image prefix from uploaded to, let's say, cleared. And for the images that contain the restricted categories, we want to change their prefix to review. And that way we can actually create another workflow for the platform admins. So as soon as any image is created with a review prefix, their workflow will start. And we will also need a mechanism to send emails. So for that, we are going to use Lambda and Amazon Simple Email Service, SES. And finally, we are going to need some sort of database where we can store the status of the entire workflow and the information about the user uploaded images and the information returned by Rekognition about the categories of the images. And for that, we are going to use Amazon DynamoDB. So this might feel a little overwhelming at first, but as we start designing the architecture, it will start making sense. And when we start designing the system itself from next part onwards, it will start making much more sense how these components are defined and how do they work together. As you can see, I'm using a diagramming tool called Lucidchart. I already imported some of the AWS services icons that we are going to use to build the architecture. So let's start with the first step. We need a website. And there are a couple of ways of hosting the website. And there comes our first architectural decision. We can use an S3 bucket, make it public, and enable static website hosting. Or we can use something that is more production grade, where we keep the S3 bucket private and use AWS CloudFront. There are advantages and disadvantages in both options. The biggest advantage of using a public S3 bucket is simplicity. So if you want something that is quick or you just want to learn about something, it's a very viable option, but it is not secure. Just by the name, that is public S3 bucket, the bucket can be accessible using public internet. And this increases the risk of data exposure. A more production grade approach is to keep S3 bucket private and use CloudFront. So that is what we are going to use here. So let's start by drawing the S3 bucket where we are going to where we are going to store the HTML, CSS, and JavaScript file for our website. Let's call this bucket as image moderation website. We are going to use Amazon Route 53 to register a domain for our website. And our users then can use public internet to access it. We'll use the CloudFront origin access control to access our HTML, CSS, JavaScript, the website content essentially. And we will use AWS Certificate Manager to enable HTTPS. Once these steps are done, once this is configured, our users will be able to enter the URL in their browser and get to our website. So let me draw the browser here. All right, so that's our step one. We have built a website and we have hosted it. But this website is not doing anything at this moment. We want this website to upload the images in the S3 bucket. And then there comes our second decision point. How we are going to enable this website to upload objects in S3 bucket? Well, we can go with a simpler option if we want, of using the API gateway and upload the files directly through S3 bucket. So let's first draw that S3 bucket. So let's call this as uploaded images. So we can use the just a note before we may have to change the name of these buckets when we start building it, because the S3 bucket names have to be globally unique. But we'll come to that when we start building the application. Okay, so this can one of our approach where our front end makes a call to the API gateway and the API gateway transfers the image files to the uploaded images. It is simpler, but not preferable or not production grade. So in this case, the API gateway comes in our data plane. So every byte of our file that the users are uploading is going to flow through API gateway. So essentially we are using our compute to not to orchestrate the data transfer, but to actually handle the data transfer. API gateway also has a file size limitation of 10 MB. And although looking at our requirements in our previous video, we said our file limitations is 5 MB on the front end itself. So it may work, but it makes our architecture rigid. Tomorrow, if the requirements change to handle files, let's say up to 15 MBs, this is not going to work. So in recap, using this approach makes it a little bit slower. It makes the architecture rigid, and it may also cost more depending on what type of API gateway we are going to use. So let's not use it. So if we are not using this, what are we going to use? And that's where we are going to use something called as pre-signed URL. So what is a pre-signed URL? Pre-signed URL is a temporary URL that the browser can use to upload the image directly in the S3 bucket. In this approach, our file is not going to go through API gateway. The browser will make a direct post call to the S3 bucket and upload the image there. So how we are going to do this? So we are going to use a Lambda function. So let me draw it here. Let's call this Lambda function as getUploadURL. Now the API gateway is going to make a call to this Lambda function, and what Lambda function is going to return is the pre-signed URL. Now the browser can take this URL, can use this URL and upload the file directly in our S3 bucket. With this approach, our compute layer is orchestrating the data transfer, not actually handling it. And that's one of the biggest advantages of this approach. It is also a good time to have our upload process, the first entry of our upload process in the DynamoDB table. So I'm going to draw this DynamoDB table. Let's call it image upload requests. And as the Lambda function issues the pre-signed URL, we can also have a step in this Lambda function to insert the upload record. Let's call it insert upload record. Okay. Okay, now we have issued a pre-signed URL and the browser has uploaded the image in the S3 bucket, the uploaded images S3 bucket. Now we want to process the image. But we do want to separate out the upload portion of our application from the processing part of our application. It is called decoupling, and it is one of the most important architectural patterns that you see in the real world applications. It will separate our upload layer from the processing layer. So uploads won't slow down if the processing is delayed. If there are any traffic spikes, they will be absorbed by the SQS queue, and the failures can be retrieved safely without losing data. This would make our system more resilient, scalable, and fault tolerant. So we are going to use the SQS queue to essentially put a message about the upload, and our processing layer is going to read from that message and process the images afterwards. So in order to do that, we are going to use a Lambda function. This Lambda function will get triggered when an object is created in this S3 bucket. So S3 object created. So when this event is triggered, it will essentially trigger this Lambda function. Let's call this Lambda function as create SQS message. So this Lambda function will read or get triggered with the object create event, and it will create a message in our SQS queue. So let's call this SQS queue as image moderation queue, and this step as create SQS message. Okay, so this queue essentially is decoupling our upload layer from the processing layer. All right, so now the message is in the SQS queue. We want to start our workflow to process the image. Remember, our goal is to analyze the image for the restricted content. So we want to start that workflow. We are going to use a step function to orchestrate the workflow, but in order to invoke this step function, we are going to use another Lambda function as a invoke function. So let's call this Lambda function as start image workflow. So what start image workflow function is going to do? It is going to poll our SQS queue to see if there are any messages. And if there are any messages, it is going to read the message and it is going to trigger our image moderation workflow. So the step function that we are going to use, let's call it image moderation workflow. Okay. So what this image moderation workflow is going to do, the first thing, and that's the entire purpose of our application, is it is going to analyze the image labels. So we are going to use a Lambda function which is going to call AWS Rekognition. So let me draw it here. It is going to pass the S3 object key to this recognition function, and essentially the recognition will then go to our S3 bucket, uploaded image, and get the file or read get image file. Okay, and once it gets the image file, it will analyze it for the different labels, and it is just going to return the labels. It is not making any decision at this moment. It will just say what the image contains. So it will return image labels. Actually, as we start our image workflow, this Lambda function, it would be a good idea to update our upload record stating that the processing has begun. You can say update upload record. Okay. So now our Lambda function, this coming back to analyze image labels Lambda function, now it has the image labels. We do want to store those image labels in our database. We can either do it in this Lambda, but in order to keep things logically separate, we can create another Lambda, which is, let's call it store image labels. And this Lambda function is essentially going to update our upload record with image labels. Okay. All right, so now we know what the image contains. Now comes a decision point. We need to check whether the uploaded image contains any restricted category. For our demo purpose, as I said in the previous video, we are going to use if the uploaded image contains cars. We want that image to be reviewed by the administrators. So we are going to use another Lambda function, which is essentially going to look at the labels written by Rekognition and move the image to a different prefix. So if the image contains any restricted categories, it is going to move that image into a review prefix. If the image doesn't contain any restricted categories, then it is going to put the image in approved prefix in S3 bucket. So let's call this Lambda function as move image to prefix. Okay. So essentially, as I said, it is going to move this image in the S3 bucket. It is going to prefix with the correct prefix depending on the presence of a restricted category or not. Approved or review. So the approved ones, if the image doesn't contain any restricted category, then it will go in approved prefix. If it contains the restricted category, it will go in the review prefix. Okay, so now that part is done, we do want to notify the user and the administrator in case if it has the restricted content. So we are going to use a Lambda function to do that. To say send upload email. For this, we are going to use the AWS SES service, which is simple email service. We are going to use it in a sandbox environment. So you will need to verify the email addresses, and that is the reason why we use when I showed the demo in the previous video, we have an email for the simple AWS tutorial. We'll come to that when we build the actual application. And this simple email service is going to send two versions of the emails depending on the scenario. So if the image contains any restricted keyword, it will send the email to the admin, and it will send the email to user as well, telling them that their submission is under review. And if the image doesn't contain any restricted categories, then it will just send the email to the user. Now, once this is done, we are going to use one last Lambda function. I'm calling it mark upload complete. So this Lambda function is essentially going to update our upload record in the DynamoDB to mark that the processing is complete. And there you go. That's our complete system. But more importantly, you just didn't see what to build. You saw how to think about building it. We started with our requirements, we applied the architectural patterns, we selected the services, and built it step by step. That's a real skill you want to develop as an AWS architect. Now, in the next video, we will take our first step in actually building this system by creating and hosting the website where users can upload the images. We'll set up S3, CloudFront, Route 53, and get everything ready to serve our application. If this helped, give it a like and consider subscribing, and I will see you in the next one.